Welcome back to our deep dive into the fascinating history of the Lucasian Professors of Mathematics. We're on our third episode, continuing our journey exploring the lives and work of these brilliant minds.
It's a pleasure to be here.
Today, we're turning our attention to a giant in both mathematics and physics, Sir Isaac Newton, the second person to hold the Lucasian chair. As STEM enthusiasts yourselves, you'll appreciate just how groundbreaking his work was, especially in the realm of mathematics.
Absolutely. Newton's contributions to math are foundational to so much of what we understand and utilize today in various scientific fields.
Now, you might already know that Newton was born in England in 1642. But what's fascinating is that despite a challenging childhood, marked by his father's death before his birth and his mother's remarriage, he showed early signs of intellectual prowess.
Indeed. There are accounts of him building intricate models and sundials as a young boy, demonstrating a natural inclination towards mechanics and problem-solving. These weren't just simple toys. They were early indicators of his inquisitive mind and his ability to grasp complex concepts.
It's almost like he was destined for a life of scientific exploration. In 1661, he entered Trinity College, Cambridge, a place that would become his intellectual home for decades, initially. His studies focused on the works of Aristotle. But like many of his contemporaries, he soon gravitated towards the ideas of more modern thinkers like Descartes and Galileo.
This shift signifies a crucial transition happening in academia at the time, a move away from classical philosophy and towards a more empirical, scientific approach to understanding the world. Newton wasn't just following trends. He was actively participating in this intellectual revolution.
And here's where things get really exciting. During the plague years of 1665 and 1666, when Cambridge closed, Newton returned home and engaged in intense private study. It was during this period of self-isolation that he made one of his most significant breakthroughs, the development of calculus.
This is a perfect example of how sometimes profound advancements in knowledge happen in isolation, driven by an individual's relentless pursuit of understanding. Newton, in his early 20s, essentially gave birth to a whole new branch of mathematics.
That's incredible. I think most of our listeners, especially those in STEM fields, understand how revolutionary calculus was. It provided a way to describe and quantify change and motion, something essential for understanding everything from planetary orbits to the behavior of fluids.
Exactly. Now, you might be surprised to know that the notation we use for calculus today is actually Leibniz's, not Newton's. While Newton was undoubtedly the first to develop the core concepts, Leibniz's system, with its symbols and formulas, proved to be more practical and user-friendly.
So, even in the world of pure mathematics, sometimes practicality wins out.
Absolutely. Leibniz's notation made calculus more accessible to a wider audience, facilitating its development and application across various fields. It's a reminder that even the most abstract mathematical concepts ultimately need to be communicated effectively to have a real-world impact.
Newton's calculus wasn't just a theoretical exercise. He used it to solve real-world problems, particularly in the realm of astronomy. He applied his newly developed mathematical tools to explain the complex motion of the moon, something that had puzzled astronomers for centuries. This was a major leap forward in our understanding of celestial mechanics.
And it's a testament to the power of mathematics as a tool for unlocking the secrets of the universe. Newton didn't just observe, he explained. And he did so with mathematical rigor and precision.
It's mind-blowing to think that he achieved all of this before the age of 30.
It speaks volumes about his genius and his unwavering dedication to scientific exploration. But it also highlights that scientific progress isn't always linear. The development of calculus was a complex and often contentious process, with both Newton and Leibniz making significant, albeit independent, contributions.
Ah, yes, the famous calculus controversy. It's a reminder that the history of science is often messy and filled with competing claims and rivalries.
Precisely. And while Newton's geometrical approach to calculus was profound, it's important to acknowledge that Leibniz's notation ultimately proved more practical and is widely used today. This collaborative evolution of ideas is a recurring theme in scientific advancement. It's fascinating how even amidst this intellectual rivalry, both Newton and Leibniz ultimately enriched the field of mathematics. Their combined efforts paved the way for countless advancements in science and engineering.
It's a great example of how competition, while sometimes contentious, can also drive innovation.
Exactly. Now, shifting gears a bit, Newton's brilliance wasn't confined to mathematics. He also made groundbreaking discoveries in optics.
Oh, yes. His famous prism experiments. He demonstrated that white light when passed through a prism, produces a spectrum of colors. It's
Yeah.
such an elegant experiment,
Yeah.
and it completely changed our understanding of light and color.
Precisely. Newton showed that white light isn't pure, but is actually a composite of different colors, each with its own unique refractive properties. This challenged the prevailing view at the time, which considered white light to be the fundamental entity.
It's remarkable how he was able to deduce so much from such a simple experiment. Did his work in optics have any practical applications?
Absolutely. Newton's understanding of optics led him to design and build the first reflecting telescope, a significant improvement over the refracting telescopes of the time. This invention revolutionized astronomy, allowing for clearer and more powerful observations of the heavens.
His contributions extended beyond theoretical understanding to the development of practical tools for scientific exploration.
Exactly. And his work in optics also laid the foundation for later advancements in photography, microscopy, and spectroscopy. It's amazing to think how many technological innovations stem from his fundamental insights about light.
Speaking of fundamental insights, we can't talk about Newton without mentioning his magnum opus, Philosophiae Naturalis Principia Mathematica, or Principia for short, published in 1687. It's widely considered one of the most important scientific works ever written.
It's a landmark achievement. In the Principia, Newton laid out his 3 laws of motion, which form the bedrock of classical mechanics. These laws describe how objects move and interact under the influence of forces, and they're still used today to understand and predict the motion of everything, from planets to projectiles.
As STEM professionals, I'm sure you can appreciate the significance of these laws. They're not just abstract concepts. They have real-world applications in engineering, physics, and countless other fields.
Absolutely. Newton's laws of motion provide the framework for understanding how structures behave under load, how vehicles move, and how machines operate. They're essential for designing bridges, airplanes, cars, and pretty much any structure or system that involved motion or forces.
It's incredible how these laws, formulated centuries ago, still hold such relevance in our modern technological world.
Newton's genius was not only in discovering these laws, but also in developing the mathematical tools to apply them to complex real-world problems. In the Principia, he used his newly developed calculus to solve problems of celestial mechanics, such as predicting the motion of planets and comets with unprecedented accuracy.
So, he wasn't just a brilliant theorist, he was also a master of applied mathematics. His work bridged the gap between abstract mathematical concepts and their practical application in understanding the physical world.
Precisely. And this ability to connect theoretical mathematics to real-world phenomena is what makes Newton such a pivotal figure in the history of science.
And then there's his famous law of universal gravitation. The story goes that he was inspired to think about gravity after observing an apple falling from a tree. While the anecdote is likely embellished, it captures the essence of Newton's genius. His ability to observe the mundane and extract profound insights about the workings of the universe.
It's that ability to see connections, to recognize patterns in seemingly unrelated phenomena, that sets great minds apart. Newton didn't just see an apple falling, he saw a manifestation of a fundamental force that governs the motion of celestial bodies and keeps us grounded on Earth.
It's a reminder that inspiration can come from the most unexpected places. But it takes a keen mind to recognize the significance of these everyday occurrences and translate them into groundbreaking scientific theories.
And Newton certainly had that keen mind. His law of universal gravitation states that every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This simple yet profound law explains why planets orbit the sun, why tides rise and fall, and why objects fall to the ground when we drop them.
It's incredible to think that a single equation can encapsulate such a fundamental force of nature. It really underscores the elegance and power of mathematics as a language for describing the universe.
Exactly. And Newton's work in gravity wasn't just about understanding the motion of celestial bodies. It also had practical applications. His law of gravitation was crucial for the development of accurate navigational techniques, which were essential for exploration and trade during that era.
So his contributions extended from the theoretical realm to the practical challenges of navigating the world.
Indeed. And his work laid the groundwork for later advancements in fields like geodesy, the science of measuring the Earth's shape and gravitational field. It's a testament to the far-reaching impact of his ideas.
Newton's legacy extends far beyond his specific discoveries. He helped to establish a new way of thinking about the world, a way of thinking rooted in observation, experimentation, and mathematical reasoning. This scientific method, which he championed, became the cornerstone of modern science.
Absolutely. Newton's work wasn't just about uncovering specific laws of nature. It was about establishing a framework for how we approach the pursuit of knowledge. His emphasis on empirical evidence and mathematical rigor transformed the way we understand and interact with the world around us.
He truly revolutionized our understanding of the universe and set the stage for centuries of scientific progress. It's no wonder he's considered one of the most influential figures in human history.
And his contributions continue to shape our world today. As we delve deeper into fields like quantum mechanics and cosmology, we stand on the shoulders of giants like Newton, building upon the foundations he so meticulously laid.
His story is a testament to the power of human curiosity and the transformative potential of scientific exploration. It's an inspiring example for anyone in STEM fields and beyond.
Absolutely. Newton's life and work serve as a powerful reminder that the pursuit of knowledge is an ongoing journey, one that requires intellectual curiosity, rigorous thinking, and a willingness to challenge established paradigms.
Well said. And on that note, let's take a moment to reflect on Newton's extraordinary legacy before we move on to the final part of our deep dive.
Newton's impact on the world of science and mathematics is undeniable. His work laid the foundation for many scientific advancements in the centuries that followed.
But even giants have their critics. While Newton's accomplishments were monumental, some of his ideas, particularly his theory of light, were later challenged and refined as the field of physics progressed.
That's right. It's a reminder that science is a process of continuous discovery. It's about building upon and refining the work of those who came before us. And even the most brilliant minds are susceptible to having their ideas challenged and revised in light of new evidence.
I suppose that's inevitable in any field of scientific study.
It speaks to the inherent nature of scientific inquiry. It's about asking questions, challenging assumptions, and constantly striving for a deeper understanding of the world around us.
Now, for those of our listeners who are keen on exploring Newton's work in more depth, there's a vast collection of his writings and manuscripts available.
Yes, his magnum opus, the Principia, is certainly a must-read for anyone interested in the history of physics and mathematics. But his work extends beyond that. He wrote extensively on optics, alchemy, and even theology.
It's fascinating how his interests span such diverse fields of study.
It highlights the breadth of his intellectual curiosity. He wasn't content to just specialize in one area. He was driven to explore and understand the world from multiple perspectives.
So where can our listeners find these treasures?
Several universities and libraries hold collections of Newton's works. The Cambridge Digital Library has digitized many of his papers, making them easily accessible online.
That's great for those who want to delve into the mind of this extraordinary man.
Absolutely. And there are also numerous biographies and historical accounts that explore different facets of Newton's life and work.
Plenty of material for our listeners to further their exploration of Sir Isaac Newton.
Indeed. Now, before we wrap up our deep dive into Sir Isaac Newton, what stands out to you most about his story, especially from the perspective of a STEM enthusiast?
What strikes me most is not just Newton's genius, but his unwavering dedication to understanding the world around him. He wasn't afraid to pursue knowledge wherever it led him, whether it was through meticulous scientific experiments, complex mathematical calculations, or even delving into the mysteries of alchemy. He embodies the spirit of scientific inquiry, reminding us that true innovation often comes from challenging conventional thinking and exploring the unknown.
He truly was a remarkable figure.
As we conclude this episode of The Deep Dive, we encourage you, our listeners, to keep exploring, keep questioning, and keep pushing the boundaries of knowledge. Who knows? You might just be the one to make the next groundbreaking discovery, to usher in a new era of scientific understanding. Thank you for joining us on this deep dive into the life and legacy of Sir Isaac Newton. Until next time, keep those minds curious.